everyone, today we are going to talk about my topic is about the securest OTA update for the ESP 8266. This is my name and my friend. And now we are going to the agenda. There are three parts. Number one, introduction. Number two, demonstration. And number three, regressions in the purchase study. And now we are going to the introduction. Nowadays, with the rise of the Internet of Things, and there are a lot of connection with the device and device, such as we apply the smart house or the smart transport. So there are a lot of small devices to and work in the class with area, and so they are so the children. And sometimes it's not able to maintain and update the firmware of the device one by one. And two more convenient and automatic. We are using the OTA update with the ESP 8266, and this is my topic. And there are some the constraints when you use these methods to more the convenient, have more the complexity and less security. And what is the over-the-air? The over-the-air update is a process of uploading firmware to an embedded device using the wireless connection rather than a several port. And this is the module of the ESP 8266. In this slide, we are to the methods to upload the data into the system. In this is the traditional upload with the server port, and in this picture, with the upload with the using the Wi-Fi when to upload the data into the system. And beside you upload the data to the system using the Wi-Fi, help the quick security. And to more security, we are use the debrief data when you upload in the system, and strong abilities the wireless or use the password or use the private key or the public key to encrypt the data. And in this slide, if you want to create a new sketch, you have to test the free space available for a new sketch. It's help enough to hold to the old sketch and the new sketch at the same time. You can use this function to get the free space available for a new sketch. And this is the OTA update process. The OTA update process how the start update and reboot. The start have the current sketch and piece, and when to update how the new sketch in between the current sketch and piece. And after the update, you reboot the system. The new sketch will copy over the current sketch is mean the old sketch. The OTA in this slide show the OTA approaches. The OTA approaches have the positive update and active update. The positive update is mean the new firmware will be brushed by the developed using tools such as Arduino OTA or the web browser. The active update is mean the ESP 8266 out market. just the downloads and the last new firmware for the distribution server. This is slide show the basic security. The basic security with using the password to check the functionality provided with the Arduino OTA. And you use the function to set up the password. This is the set up the port. This is set up the your Wi-Fi, and this is your password. And in the Arduino OTA, can do authentication of log with using the device MD5. And to integrity of the transfers data is verified on the ASP side using the MD5 JSON. In this slide show advanced security. To do smart security, we have those advanced security like in this slide. You can see in this slide, in the left hand side is mean the developer. The developer have to the baskets, and in this it means in this side, and how to the signature and the compliant binaries. The signature to obtain the signature, we have has the binary code by the developer's private key, and then obtain the signature and the compliant binaries, and then upload it in the system using the web server or the HTTP server. In the right hand side, in the ESP will verify the package with the public key. If the code is modified or changed by another one except the developer's private key, it will the public key is not matched, so the ESP cannot upload the data. And in this slide is the compression. The compression in the binaries can also to compress to more compact for delivery. And the firmware of the ESP8266 support built-in the compression adjuster for OTA. You can see in the picture using the firewall to encryption. And the process of the encryption is the same the advanced security. In the advanced security, this is mean the compliance binary, and in the compression, in this the compressed binary. And then we upload the package into the system. And it's the same the process in the advanced security. And now we are going to the demonstration. In the demonstration, how the 4 parts. The number 1, non-secure OTA update. The number 2, password secure OTA update. The number 3, TLA secure OTA update. And finally, the side binaries OTA update. And now the next presentation, please invite Hai to present in the next presentation.
Rồi. Hello. Hi. And I will continue the demonstration about the secure OTA update for ESP. So let's have some little recall if you don't know about the memory format. So in the computer architecture world, we have two memory format. The first thing is the big endian, which is mostly used in the personal computer. In such the architecture like x86 and AMD 64. And the second one is the little endian, which is mostly used in ARM-based or mostly microcontroller architecture. And this is also an example, the representation of 32-bit hexadecimal in memory. So we have here a 22-bit word, also known as a double word, and the address. This is the first byte. This is the first byte, the second byte, the third byte, and the fourth byte in a 32-bit word. And for big endian computer, this hexadecimal will be presented as following, and you can see it's the same order with the original one. Meanwhile, the little endian will reverse the order, so we can see here the order is reversed. And let's get things started with the first demonstration. We have a web updater example from the Arduino. After you install the ESP8266 core software for Arduino, you will find a lot of examples for the ESP8266, and this one is one of them. So the program procedure of the web updater: first, it will connect to the Wi-Fi, and second, it will set up and start the multicast DNS domain name server, and next it will set up and start the HTTP update server. This one will handle the OTA program over HTTP, and the next thing is set up the I/O, and the last one, it will launch the main program pool. The main program pool is a while loop. It will handle the HTTP client and new OTA program, and then control the I/O. So you can see here, after you combine the source code, it will create a binary file called webupdater.ino.bin. And take a note in your mind that we will examine the binary during the OTA update process. So after you upload this program to the device, you can take a look in the serial monitor, and the device will let you know its HTTP update server is ready, and you can open the browser and access this address so that you can see here in the web browser, it's a simple graphic user interface that you can choose the firmware or the file system will be uploaded and updated to your ESP8266. So this is how we update it. you click choose file and then point to the combined binaries and then click open. After that you see here it is shown here, and you click update the firmware, and after the update progress were made successfully, it will automatically reboot, and you can observe in the serial monitor it will show a reboot log and a new program will be launched. But the beginning of the risk will be shown right now. I will use the Wireshark to capture and a Wi-Fi adapter to capture the network packet during the OTA update process. And you can see here, this is I will filter out the IP address. This is the IP address of my ASP 8266, and you can see here this is the message that was transferred over the network, and you can see it will show it show here the firmware, the web updater .bin. But why is it risk? Because we can take a look in the message. Yeah, after the stream you can see it have some button here, the 0D, OA, OD, OA. They are on hexadecimal code, and take a look at this one. You can see this is the first byte, the second byte, the third byte, and fourth byte. Why this one is important? I use a simple program, the Asst, to ring out the hexadecimal of the combined binary, and you can observe that one. The binaries can be captured over the network. If someone know the Wi-Fi password and use the Wireshark, that person can capture the binaries code that I have shown you here. And why this one have the result order? Because I have shown you about the little and big endian. So after the attacker, after they gather the information, the compiled binaries, and they got a technical reference which contain a lot of information about the ESP8266 memories. They can make the reverse engineering to know what will the firmware doing with the system. So the first demonstration is not compatible and it's not safe to use. So how about the second one? The second one, it has the same procedure with the first demonstration, except it added a password authentication, and it will handle the new OTA program. So we can take a look in this source code. We will define the username and password for the password authentication progress. Okay, after we upload the firmware to the ESP and we go to this address, it will show a login dialog, and we type admin and admin here to sign in, and it will lead you to the graphic user interface to update the binary file OTA. And however, the result when we use the Wireshark to capture the packet, and the attackers they can still capture the binaries as we have shown here. So, and let's take a look in a small observation. We dump two different firmware for the ESP, and we can see the first bytes they have the same value. So if the attacker have time and they observe the data they capture, they can make some conclusion that there will be a byte button that let them know which is the start of the firmware. So they can use this value and use the lookup tool to find this value. So when the developer upload a new program and the attacker still in the network, he can capture everything and use this pattern and got this value, and they know, I found a new firmware update for these devices, and they continue to capture the new firmware. So this issue lead to the third demonstration that we use. This is about the TLS, secure OTA update. It will start on HTTPS server and with password authentication, and it will handle the HTTPS client and handle the new OTA program. So we can see here in the source code we have defined some certification key and the public key for the web browser to access the ESP over HTTPS, and we can open this link to access the site. We have to log in to the site, and also we can see here this website is over HTTPS protocol, and we choose the firmware, upload it, and wait for it to rebooting. Don't forget that we use the Wireshark to capture the packet, and we filter out the device's IP, and everything now is encrypted using the TLS. And we use this bytecode pattern to look up in every network packet that we have captured and find it, and we can see here no packet contain those bytes. Why? Because everything now is encrypted, so it's become more safer. So it becomes safer. But however, we just talk about secure the way we transfer the data over the network. How about the combined binary itself? If the attacker after they gather all the information, they know very well about the binary source code, and they make some change, and they return to be a developer to update the firmware for the ESP8266, and the device cell cannot return to be flashed the modified firmware. So this issue leads to the final demonstration. We will shine the binaries to be served over the air. So first we will generate an RSA 204H private and public key pair, and this figure show you how can we make the key. We will use the Open SSL and chain Zen RSA and make the private key and the public key, and we put these two keys inside the folder with the same folder of the ESP source code. So the Arduino IDE can read our private and public key, so that it can automatically make the sign procedure. So we will ring out the public key and embed this public key in our source code. So this is the RAM procedure of the final demonstration. First, it will connect to the Wi-Fi, and then it will set up the signature verifier with public key and set up the I/O, and then it launch a main RAM pool, and it will automatically check and download new firmware from the server. And as we can see here, after we combine and upload the compile the RAM, it automatically shine the binary, and this is the final output of this process. So at first we need to upload this one to our ESP, and we also need to set up engines to serve the static files over HTTP. Why? Because we will set up an update server, and we copy the signed binary to this folder. I assume I will use this folder, and change the file name, or we keep it. So we will set up the sign enable default of the engine and point the root location to this folder, so that an HTTP client Asst can download files from from this folder, and we also see here we use the core RAM to test the server, and I can download the binary successfully. So the ESP now can access the HTTP server, and you can see here after it connect the Wi-Fi in 5, 4, 3, 2, 1 second, and it downloaded the program and then flash it and reboot the system automatically. So in this state, the ESP is loaded the new RAM, and I stop the engine so that in this state it cannot connect to the update server. So there is also another advanced technique that we will use the HTTP update to invoke the server-side update script, and we will maybe send out the current version of the ESP so that the server can check. If they have the newer version, they will return the new firmware for the ESP, and it will update the firmware and return the result. So, however, last but not least, if the attacker can access our device physically and use specific tools such as the USB to TTL model and the oscilloscope or computers, they can read out the RAMs and flash the new RAM to this device. And our final project is based on this document. This is the official over-the-air updates for the ESP 8266. And further study, this is another study. They research and make a mathematics-based solution to secure the over-the-air reset. And the second study is this one is a survey for the over-the-air secure in the connected vehicles. The connected vehicles is a very huge and valuable market that will attack many attackers. So that's all about our presentation, and thank you for listening. And if you have questions, please let us know. Thank you.